We are on day 5 of Advent of Code. So let's switch over to that display. There we go. And I'm trying to think of testing, because testing is always a good thing to do, and I don't really have my config set up for testing. So I feel like I want to spend some time, not right now, but spend some time maybe later trying to figure out a good way to set up testing. Epic Blog says, hello, Epic Blog. Epic Blog says, I saw someone post a Google search trends on Twitter which showed how AOC puzzles affect what Rust-related searches people do. Oh, yeah. Like at the beginning of AOC, the first bit was like how to read a file. And then a few days later, when hashing came into the thing, the search trend popped up with hashing. Yeah, that was an amusing little chart. Let's, I'm trying to, this thing is in the way. Okay. Let's go here. Let's go back to the calendar, and we are on day 5. So let's get set up for that. Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates. But because the needed supplies are buried under many other crates, the crates need to be rearranged. Okay. The ship has a giant cargo crane capable of moving crates between stacks. To ensure that none of the crates gets crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. All right. So it sounds like we're just doing some puzzle input that's going to have a bunch of instructions. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. So we're on day 5 and we're still on the beach. Okay, when are we going to enter the jungle here? No wonder they can't find 50 stars in 25 days. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure. Okay, so this is basically the test input. Okay, so this shouldn't be too bad to parse, right? We just need to extract the numbers. This seems a little trickier, but maybe we could come up with some clever idea here. I'm just thinking, if all the stacks are like this, let's take a look at the input. Let's grab the input. 2022-05, 511 lines. Oh, okay. So we have 9 stacks. I wonder if that's for everybody. Everybody gets 9, or if it can vary. And then we have a bunch of move instructions. But maybe doing 9 makes it easier to parse out these things, but whatever. I'm hoping that the input is all valid. So whenever it says move 11, there's going to be at least 11 entries in that stack. As I'm reading this as move 11 crates from stack 7 to stack 2. That's why I'm reading that. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom. Crate N is on the top. Stack 2 contains 3 crates, MCD. Finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. In each step of the procedure, quantity of crates. Yeah, so it's just move 1 crate from stack 2 to stack 1, right? And then we have an example running through that. CMZ, what's CMZ? The elves just need to know which crate will end up on the top of each stack. Oh, okay. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. Okay. Cowface Dew says 9 stacks for me. Okay. So maybe everybody gets 9. After rearrangement is complete, what crate ends up at the top of each stack? Okay, so we have the input. The next thing we'll do is, let's check it in. Actually, you know what I could do? I'm not going to pull up my test get input script right now because it has my session key in it. But it would be nice for this to do also get add input. Git commit -m 2022 day 5 input. I mean, it could do that all automatically. with the no verify on there. All right, nvim mod. Oops. 2022 mod. All right, got to get bacon going. And right now we have day 4 running. Okay, so let's see if we can fix that. And then this is not day 05. And now we finally get this thing to wrap. Yep. Create the file, go to the file, fill in the template, delete the 0, and it's computing. There we go. All right, perfect. So now we have this bit. So parsing, should we split it out into, now what is this on? This is on a ship. Is that what it said? Yeah. They have to be unloaded from the ships. Okay, so that's what we'll do, is we'll call it a ship. And the ship is going to contain, and here's what I'm thinking, is that we could just do vectors, a vector for each one of the stacks, and then a vector for that. Because all we care about, right, we're moving, how do we move? Do we just chunk it over, or? Crates are moved one at a time, it says. So the first crate to be moved is D. I see. So if we're going to move, we move this here. All right, so we just do an operation that goes pop here, push here, pop here, push here, pop here, push here. So it's just a vector of vectors, vec, vec. And we could just store it as char, right? And then we have the instructions, which is going to just be a triple tuple for each one. Or we can make it a little struct. Let's do that. Struct move. And it's going to be amount, from, and to. Right? And then we just have the instructions, which is going to be effective moves. That seems like a good way to approach it, I think. Let's find out. So we're going to say for line in AOC lib read lines from input 2022-05.text. Oh, we have to determine what we're doing. If it starts with a move, oh, is there a blank line in between? Blank lines get automatically skipped by this code, so we don't have to worry about the blank line. But we can say if we can set words equals line split by that, collect into a vec of stir, and then each word we can take a look at it. If words of 0 is equal to move, then we're generating a move instruction. I think that's all there is, right? I remember we just scanned it, so it should be in my brain, but it isn't. Yeah, so it's just this stuff here, which we've now split into words. Oh, we have this line we need to ignore somehow. I guess if it starts with a space. No, we can't just say starts with a space, ignore it, because that starts with a space and we don't want to ignore it. If we ever want to use the test input, right? I guess we can look, well, first we look at move. And if it's a move, we just parse the move out. That's easy. If it, I can't check for a bracket at the beginning either, because this line doesn't have a bracket. I could just say if it contains a bracket. Let's do that. All right, so first off is move. So we're going to say let amount is equal to words 1, parse, size, unwrap. And then we have from and to. This is 3 and 5, right? We have 1, 3, and 5. Yep. So we just say self instructions push move amount from 2. All right. That should do that, we can actually take a look at how many moves there are by doing this. Self instructions len. Right, we should be able to run that. Epic Blog says, I wonder how common it is for people of AOC as a reason to try a new language. That was what I did, right? So I learned Python through AOC and I learned Rust through AOC. So I think it's fairly common. I know he runs a survey every so often, saying what made you do this, and people have posted other surveys too on Reddit. Cafe Stew says there's a double new line that you can use to check. That's true, except my little library routine strips out blank lines, so I can't check that. Kafka says, what a parsing mess we get for today, huh? Okay. Well, I mean, so far it's straightforward. We have move, and now we got to figure this out. I think, so this is all regularly spaced. There's only a single character, right? So there's 1, 2, 3, 4, 5, 1, 5, 6, 7, 8, and 9. So they're all separated by 4. So if it doesn't start with the word move, we can say if words 0 contains an open bracket. Oh, no, we want to save lines. Then we know, oh, this should have else. Then we have one of these things. So what we can do is we can say, we only want the first, the fourth, and so on. So we can say for ch in line.chars enumerate, and then we can do what we can do is do a filter. Filter like that of I and C, and we can say if I minus 1 mod 4 equals 0, right? Because if we do 1 minus 4 is 3, 5 minus 4 is 4, 9 minus 1 is 8. So if it's 0, then we match our filter, and we can say the stack we're on, right? We're on a array of stacks here. That's what we have here for a ship. So the stack we're on is equal to, oh, not ch, pair dot 0 minus 1 divided by 4, right? And then we need to make sure there's enough in here. We can say while ship.len is less than stack. For the first stack it'll be 0. We want to say stack plus 1 ship.push back new. And then here we just say ship stack of, ship of stack push pair.1. Right, pair.1 is a character. Oh, thought it would be. Let's see, what did I do wrong here? I thought pair would be, okay. Let's see what I did wrong. Let's compile it. Hakuma Vitata. Hello. Just finished today's AOC and now I'm cleaning up my solution while listening to your approach. Okay. I'll try not to make too many loud noises. Oh, right. Self-ship. Duh. And expected a closure that returns a bool. Right? Is that what it says? Oh, because, right. I'm trying to destructure the tuple. Okay. All right. So we're still not there. This gets an underscore and we panicked on arith. Oh, subtract with overflow. We can't subtract 1 from 0 on usizes. Oh, you know what we can do? We can cheat. Because we're doing a mod. So we can just add 3. Right? In modular arithmetic, adding 1 less than the mod is the same thing as subtracting 1. 501. I don't think that's the answer. Oh, that's how many instructions there are. All right, so we were able to parse the instructions. That's good. And we're not using these fields. That's also good. Kafka says 3 equals -1. That is, yep, that's true. I don't know if you, I didn't look at chat until now, so maybe you said that before I did. If so, apologies for stepping on you there. All right, so now we have all the instructions, and we have, which are here. We have the ships. Actually, you know what we should do is just print it out. Let's see what it looks like. See if I parsed it correctly. Println debug out self ship. How does this look? VCWLRMFQ. Ooh, I don't want spaces. Okay. Because I don't want to pop a space, right? We don't care about spaces. Let's eliminate those too. I'll change that here. We can say C is not equal to space. And that's going to make this thing wrap. Yeah, dang it. Oh, yep, we can do this. Dang, I guess we can. There we go. Okay, so now I've eliminated the spaces. Let me take a look at the input. All right, so we have VCW. Oh, I want these the other way around. Because I want to be able to pop off the end and push onto the other one. I don't want to pop from the start. Kafka says enumerate definitely better than my nth advancing. Oh, okay. I guess it's a, you know, everybody has their own approach, right? I don't know if, so nth. Oh, do you just, okay. That makes sense. I understand the nth approach now. All right. So I actually want to do this differently, right? Because I want to be able to push onto the front, but pop onto the back. And you know what that means. I'm going to push on the front during parsing, but then the rest of the work pops off the back. So we're going to make these vecdex. Or vecdq, depending on how you like to say it. So this needs to be push front. Vecdeq new. Okay, so now I think it's in the correct order. Oops. Right, VCW LRMFQ. VCW LRMFQ. Okay, perfect. So now we just have to do the instructions. Right? So part 1 becomes for I in self instructions. I'll put it, oh, I always by default throw in a reference on there so we don't consume the instructions. And now it's just amount from and to. So we can say for in I.amount, no, 0 dot dot. Right? And then we'll have to pop from the back and push to the back on the from and the to. I don't think we can do this. I don't think you can say self I to dot push back self I from pop back unwrap. I think Russ is going to complain that we're reading from, oh, this should be self ship. Right? I think Russ is going to complain that we're reading from self ship here and writing to it here at the same time. But I want to see. Oh, what were we even looking for? What crate ends up at the top of each stack? Okay. Let me first see if this builds, because I don't think it will. Yeah. So we can just split this into 2. Let crate equals this. Oh, we can't use crate. That's right. Ship crate. And then push back the ship crate. That should build. Yeah, it does. Okay, so now we just have to build up the top of each one. right? So it'll be V, L, B, G, and so on. Okay. All right, how hard could that be for stack in self ship? I'll let mut answer equals to string answer dot push. What's in vecdeck? There's a way to get the last one, and it's not called last for whatever reason, and I forget what it's called. Last item. No, I guess we can just look here. Yeah, see, it's not called last. Is it just back? Provides a reference to the back element. That's fine. References will work. I could just deref it. Stack dot back dot unwrap. And then the output is just answer. Kafka says pop back. Oh yeah, I could pop it. That's true. And this failed. Oh, index is 9. Right. All of these numbers are off by 1. So from we have to subtract, to we have to subtract. All right. There we go. Who knows if this is right? The website does. Yay, that's the right answer. Okay, not too bad. Is there anything we can do to clean things up? Oh, I can get rid of this print line. Let me check in with Clippy to see if Clippy has any thoughts on the matter. We're all good. Kafka says off by 1 errors. Yeah, exactly right. Exactly right. Because the from and to are 0 based, but the instructions are 1 based. So git status, git add source, git commit -m 2022 day 5 part 1. All right. I'm expecting part 2 to be a little tougher. All right, let's switch back to run and take a look at part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. Okay, so we have another off by 1 error here. So I'm not the only one making these mistakes today. Did they say Crate Mover 9000 up here? No, they didn't. They just said giant cargo crane. All right, maybe that's just an oversight. Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, extra cup holder, and the ability to pick up and move multiple crates at once. Oh, okay. So now instead of one at a time, we do all at a time. The crates stay in the same order. Exactly. Okay. So in this example, it would end up being MCD, and it was CMZ. Okay. Very different output. Before the rearrangement process finishes, update your simulation so the elves know where they should be. So it's the same answer. We still want to know what's on the top of each stack. We just manipulate the stacks differently. So what this means is I want to change everything here. I want to actually do a let ship equals ship self ship clone, because I want to reuse the original order of the ship. So we can get rid of these selves now. And this should come up with the same answer, right? And it doesn't, because I didn't make this mutable. Yep, those are the same answers. Okay, good. So now part 2 is kind of the same. We don't actually need to clone the ship this time, but I'm going to just do it for consistency. And now it's not for I and amount. We actually just peel off how much we want to remove. Is there a way we can split a partition point? Oh, this is the partition point of the internal internal pair of vecs where it's partitioned. Okay, I don't want that. I want to know if we can split. We can split off. What is split off? Kafka says split at. Yeah, then the naming consistency is not all that great in the standard library. This should be split at. You're right. Splits the DQ into 2 at a given index. Perfect. That's exactly what we want. So all we have to do is say we have to figure out what the split point is. Split point is going to be equal to the ship of I dot from dot len minus I dot amount, right? And that's where we want to split it. And now we have to do it in 2 steps. Let removed is equal to, and this just returns, oh, it doesn't even return an option. It just returns a vecdec directly. Okay. That makes it a little easier. So ship of I dot from dot split off split point. We could do that in one line, but I think it makes it easier to read. And then we can say ship I dot to. I think there's an append where you can append a, there is. Yeah, so you can take one vecdec and append it to another vecdec. So we can just say append, removed. Does this need anything? Ampersand mute. Okay. It has to be immutable, which means this has to be mutable, right? Does this build? It does not. Oh, because I forgot to put an answer. Let's just do a temporary answer here, because I just want to see if this builds. Kafka says split at returns slices, split off returns vecdecs, if I read that correctly, so I'm all for different names here. Ah, I see. Yeah, I can buy that argument. And if you type in split at and it fails to compile, you just have to remember, oh yeah, that one's split off. So if I do that, it should say kaboom. It would be nice to say there's a similar function called split off, right? Because it does that sometimes. And now we just have to generate the output the exact same way. And we get this mess. And it is the right answer. Excellent. Kafka says you can use extend to move removed instead of mutably borrowing. Oh, okay. Maybe that's cleaner. Where's extend? Oh, maybe that's a trait implementation. Kafka says no hidden messages. Oh, yeah, in here, yeah. So there's an extend. I'm just looking here. There it is. Okay, so let's try that. Why not? I mean, we're throwing away removed anyway, right? It's getting dropped at the end of the loop here before the next instruction. So either way, but yeah, that way we don't have to have a mutable borrow. Yeah, but again, we can't put this inside here because we'd be borrowing this immutably. Oh no, they're borrowing this mutably here, and we're borrowing it mutably again here. So they can't do that. Even though, technically this finishes, right, before this executes. So technically you're not doing it twice, but I guess the compiler isn't smart enough yet. Handafal says, show me how you're parsing input. Hello, Handafal. Yes, I will show you how I'm parsing input. So it's basically, I just get all the lines. I have a little function here which reads an input file and returns a vec of strings. And then each line gets split into a word. So I basically split it by spaces. Let's take a look at the input. Why am I not able to type? If I hit tab, then should be able to, nope. I thought I could hit like up and down to get there. Okay, right. So I basically split it into spaces. So this is a word, this is a word, this is a word, and so on, right? Then I say if it starts with the word move, then I know that 1, 3, and 5 are each the amount from and to, respectively. And I just parse those into usizes. And I push that into a little move struct I created. I could have made a tuple, but I just made this little move struct, which contains them all by name. So you could refer to them by name, then rather than remembering .0 is amount, .1 is from, .2 is move, for example. Then I just check to see if the line contains an open bracket. Oops, I'm in the wrong window. Because lines with open brackets are the ones that have the stacks. Right? I then convert the whole line into characters. I enumerate those characters, so now I get a 0 and a 1 and a 2 and a 3 and so on. I skip anything that's not divisible by 4 and not a space. So that means I'll capture the V, I'll skip the space, I'll capture the B, I'll skip all these spaces, and I'll capture the C. And the stack it goes on is equal to the enumerated value minus 1 divided by 4. And that gives us the stack number from 0 to 8, actually. And then for each entry in the stack, in the ship, I'll push a new vec deck to create a stack for each one. And then that character gets pushed on the front of the stack. So that's how I'm doing the parsing. Kafka says, I'm close to writing an input macro that reads based off the module name, but proc macros are hard. Oh, you're right. I could just do parse. Kafka says parse should work here because Rust sees that I'm putting it here. And these are all usizes, so therefore all these must be usizes. So that should work. I'm kind of annoyed that, can't infer the type. Oh, because I'm subtracting 1. Yeah. Dang it. But it can infer the amount. Oh, still can't. That's disappointing. Okay. But it should be able to do amount, right? Yeah. That's too bad. Kafka says, I'm close to writing an input macro that reads based off the module name, but proc macros are hard. Okay. Yeah, I actually store the name of the year and the day. I call it name, but it's basically I store the year and the day in here. So technically what I could do is I could write a little function which reads, HTTP get. Right? I could just do that so that it would run for anybody and get their input. Right? That would be, but I don't want to do that. Let's make sure that builds. Okay, I think we're clean. Anapha says, here's my parsing. Let's take a look. Copy link address. Paste and go. Oh, yeah, for Windows. Okay, that makes sense. And then you split the first part from the second part. That makes sense. Okay, so now we have the crate info and the instructions info. You could probably do a split once here and get these directly. This add is annoying. Let's do that. Okay, and then we get all the columns. So you're doing something similar here. J times 4 plus 3. Right? And if it's empty, you continue. When would it be empty, though? And otherwise, you push it here. Oh, you push the nth. That makes sense because you're skipping the open bracket, and it can't be none. Okay, and then you just parse the instructions. Count from 2. Oh, right. Okay, so you're doing something similar here. And then where do you run? Oh, this is just your parser. Okay. I was going to look at how you ran it, but that's good. All right. Very nice. Very nice. Hand of Loss says because I trim white space. All right. Let's take a look at the leaderboards. Private leaderboard. Let's see how we're doing on Chales. I think I'm pretty much hovering in the same spot every day. I think it was 83 yesterday. Did I move up or down? I must have moved down. Oh no, I moved up. Look at that. I'm at 60 now. Let's see if I can break 50 before the end of the and then toggle bit. I'm in 10th. Hand of Loss says, here's my solution. Okay, let's take a look. Oh, there we go. Yeah, so exactly. You pop one and you push. Okay, same thing there. And then, oh, you're doing it one at a time. Okay, I see. Very good. Yeah, I took a slightly different approach in that I'm taking chunks at a time, right? Oops, didn't mean to do that. Right, what I do is I split the entire thing off at once and then extend it. I think extend still does one at a time. And to be honest, split off probably also does internally to build the vec deck here. I don't know if it's smart and it's able to just grab a chunk. Anyway. Karki says, I went on a trip trying to avoid that allocation at split off. Yeah, so it's okay. All right, that is day 5 done. Let me just check in with Clippy real quick just to make sure I haven't broken anything, and then git commit -am 2022 day 5 part 2 done.